Okay, hello everyone. My name is Timothy Lee Grant, and today we are going to be continuing. Oh my goodness, outside there is a. I don't know what's going on outside, but commotion. Anyways, we are going to be continuing the Neetcode journey. So let me make myself a little bit smaller and start here and then come down here. So longest consecutive sequence. All right, let's go. Let's go. Let's go. So given an array of integers num, return the length of the longest consecutive sequence of elements that can be formed. Okay. A consecutive sequence is a sequence of elements in which each element is exactly one greater than the previous element. Okay. The elements do not have to be consecutive in the original array, and it needs to run in O of n time. Okay. So let me just reread that because I didn't quite understand what's going on. And then later I'll look at the examples. So given an array of integers nums, okay, so we have an array and they're integers. And I need to do what? I need to return the length of the longest consecutive sequence of elements that can be formed. So I think it means I'm given an array, and this array will have numbers in it, and I need to find what is the longest element of, like, if we have 0, 2, 4, 6, 7, 6, so 0, 2, 4, 6, 7, 8, 9, 10, I would return 5 because I can do 6, 7, 8, 9, 10. But then the other ones are not consecutive. Let me see if this is what we have here. So 4, 5. Okay, 4, 5. No. 2, 3, 4, 5. So there's 4. Yep. That makes sense. So the brute force method would be to just iterate over this I would come here and see that it's a 2, and then see if there's any other one that is a 3, and say I found a 3, and then I would come in and look for a 4, and then I found a 4, and I would do that until I broke. Meaning I would come here, I would find a 6, and then I would go and try to find a 7, no 7. Okay. So let me just say that in terms of like how a for loop would work. So I would come here, I would look at this one, and I would iterate over this. I would come here and look for 3. Once I found a 3, I would come back here and look for a 4. I found a 4. I come back here, look for a 5. I find a 5. I come back here, I look for a 6. I don't find a 6, so I break. And then I come and I look here, I find a 20, so then I come look for 21. No, so I break, and then I come here, I see a 4. Okay. So this has to be O of n time. So what is a way that I can think to okay, I have a ridiculous way. I just want to see if this works. So for element in nums, okay, my set dot add element, okay, watch this, my set is equal to a set like this, then I break, okay, so I only did that one, I iterated through in elements, then I'm breaking, so it like resets that, right? Then I come here and then I say for element in nums. Now I have to make sure that every operation that I do in here is O of 1. So checking. No, that doesn't work because then I would have to. No, never mind. It doesn't. I thought I would be able to cheat my way through it. It doesn't work. Okay. I was thinking about, looking up in a set is O of 1 times, so I might be able to, but then I realized, oh no, I would need to go to the next element. That's unfortunate. Okay. Is there some kind of way to I think dot sort is in log in. Is that right? Let me check. What is the time complexity of Python's dot sort? Okay, yeah, so I can't do sort. That's unfortunate. Okay. I was thinking about sorting it, and then I could use kind of like 2 pointers to iterate through it. That is not a viable solution. I understand that this is in the hashing section, the dictionary and hashing section. How would I do a dictionary to solve this? I would need a key and value. All right. So we already know the brute force, that's fine. Is there any way to identify the start of the sequence? For example, this. Only 1 and 10 are the beginning of a sequence. Instead of trying to form a sequence for every number, we should only consider So maybe if I do have like my set is equal to set like this, and then element in nums, I do my set dot add element, okay? And now I can try to identify the start of each of them. Okay, so I can go if element plus 1 not in my set, then that means minus 1, the one previously before me. If that is not in my set, then I found a leading number. Okay. I don't know. Okay, but how does that help me? Okay, maybe I can do my dict indexed at the leading number, so element Okay, so now I have a list of all of the leading numbers. For number for leader in leading numbers. Okay, so I'm going to get those leaders. And now I'm going to go for, and now I'm going to be suspicious of this, but for, or no, while, okay, candidate in my set. Okay, and now what is candidate? Candidate is going to be, we're going to start off by having it be the candidate candidate is equal to leader plus 1, okay? So it's going to be the next one. I'm going to say, like, if the next one is in my set, then I am going to do my dictionary indexed at or do I even need that? I could just do current plus equals 1. Okay, now I need current is equal to 0, and I need maximum is equal to 0. So now I need to say if current is greater than, no, I can just do maximum is equal to the max of current and maximum. Okay, so then I need to increase candidate by 1, and then it's going to check if it's in the set. So this cannot run. So I'm going through each of the leading numbers, and I am checking if, so for this one I would start at 2, and then I would see if 3 is in there, and it is. So then I would go check if 4 is in there, and it is. And then I would go check if 5 is in there, and it is. Then I would check if 6 is in there. And each of the checks is O of n times. It's in a set, okay? And then I would see I would see 6 is not in here. And then I would break and go to the next leader, and that leader would be 10, I think. And now notice how I'm not looking at 4 now, because 4 was not a leader. So I'm not doing O of n squared time. I'm now just looking at 10, and I say, is 11 in there? Nope. I'm not checking 3 or 4 or 5 because I've already checked that. And by just by the way numbers work, if you have a leader and that leader has other numbers in sequence with it, and then you have another leader, which means that there is a break, that second leader, all of its numbers are going to be higher. Okay. And so then I think I can return the maximum. I think this works. Let's see. No, it doesn't. Oh, right, because this is we have to have current to have the first number in there. Let's see if that works. Okay, yeah, that makes sense. Wrong answer. No, okay, well, we got it wrong anyways. Output is 0. Right, okay. Okay, there we go. Cool. So let's go to the solution, see how they did it. So result equals 0. Store is, oh, this is brute force, so this probably isn't the good way. So num in nums. So yeah, this is the bad way. Sorting, I mean, that's fine as well, but we're not doing sorting. Here we go. Hash set versus hash map. Kind of curious then what's the difference? I always just okay. So num set is equal to a set of numbers. Okay. Of num. Set nums. Oh, so we're just putting nums in the set. Okay. I was like, wait, hold on. Okay, that makes sense. Longest is equal to 0, so for num in num set. Okay, so we're doing an O of N operation right there. If it is a leader, if it's a leader, then we say that the length is 1, okay? Because we're starting a new set, or a new string, not string, but like consecutive thing. I can't even say list because all of those terms are used in algorithms. Anyways, so while num plus length in here, we increase length, okay. Yes. Longest is equal to, we're updating longest, and then we return. Okay, that makes sense. Hash map, okay. Now we have, instead of a set, we have a default dictionary, which takes integers. For num in nums. If not MP, indexed at num. Do I have any more coffee or something? No. Fortunately, I do not. Sad. Okay. So in nums, so I'm iterating through each of the elements, and I'm using that as my dictionary. So I'm seeing if it's already in my dictionary. If it is in my dictionary, then I don't do anything. If it's not in my dictionary, I assign this is equal to I'm guessing we're going to say length of the previous one, okay, plus the length of the one ahead of me plus 1, okay, plus myself, I think. Now, the minus MP minus 1. Okay, let's see what it says. All right, so the core idea is instead of sorting the array, which would take n log n, this algorithm builds and merges sequences on the fly using a hash map, okay, that stores the length of the sequence at each number. When a new number is found, if it's not already in the map, it checks if the previous element and the element above it exist. It calculates the total length of the new sequence. It updates the boundaries of the sequence. Okay. So this is the boundaries. Left boundary, right boundary. Okay. Let me come back here. This is the left boundary. So this is its length. This is its length, right? So I'm indexing where I currently am and minusing the length of the previous one. So I'm getting the first element, and then I change that to be the length of this total thing. So I'm updating the new sequence. There we go, that's the word. Then I do num. So now I'm doing the same thing, but on the other side. So I'm updating the end of it to say that this is our length. So that the beginning and the middle are now going to have the length of the total array or sequence. Okay. That also is a little bit trippy. Okay. Cool. I mean, that's an interesting way of doing it. Okay, trying to take that in, trying to let my brain settle on that one. Okay, yeah, interesting. Cool. So we were able to get this problem, and I am going to keep going, and we're gonna hit the next problem in the Leetcode roadmap. So if you want, subscribe to this channel. I would love to have you around, and thank you for watching. My name is Timothy Lee Grant. I'll see you guys in the very next video. So goodbye.